a very basic question, whether India is going to win this World Cup or not. So this question can be answered with all the different inputs, that whether India is going to win all the league matches or lose some matches, whether India is going to win all the knockout matches. So an event can be done in various different type of approaches, and they all give importance to the total success of the event in bits and pieces. Now, if I am finding out the occurrence of any event and I am taking part all those bits and pieces, so in totality I am finding out the total probability of the event. So this part of the probability is actually dealing with this specific question and answer to this question, that whether any event is happening and if we are considering or not all the bits and pieces that are making this event possible. So to get a very understanding of deep rooted knowledge, let's start on.
So next in the order is total probability theorem. Let's understand what is this. First of all, let's understand the basic nuances, fit and crux of the total probability theorem, and then after all we'll go to the mathematical formulation and we'll do an example based on the formulation of total probability theorem. So let's start. Partition of sample space. This is a thing which is utterly important, because this is what is going to help you understand what is total probability theorem. Considering a sample space S, that A1, A2 till An be a set of mutually exclusive and exhaustive set of sample space. First, let us understand what is mutually exhaustive and exclusive set of sample space. Mutually exclusive, as we have learned earlier also, mutually exclusive gives us a way that if one event is happening, the others will not occur. So this is what is mutually exhaustive. Others will not occur. An exhaustive set of events are those set of events such that when you combine all the sample points, you will get the complete sample space. This is what is the meaning of exhaustive. In sample space, you consider all the events from A1 till An and you combine the sample points, and after combination you will get the complete sample space. So this is what is the pictorial representation of total probability theorem. In this, let us understand what is exactly happening. See, this is an event A. Now consider, suppose I have taken this to be as A1, this as A2, this as A3, and it will go on such that this becomes An minus 1 and the final one is An. So what I have done, I have divided my complete sample space S into n set of events which are defined by A1, A2, A3 till An. Now if I am taking any event A which is containing some smaller portions of either all or a part of the complete events, so that is how I am defining my any other event A, and this is what it will represent. So can I say that it is nothing but small portions of A2, small portion of A1, small portion of A3, small portion of A4, small portion of An minus 1 and small portion of An, and if I can club all of them, I will get the complete A. So this is what the basic meaning of this is. And these even A2 till An events are said to be the partition of the sample space into n parts. So total number of events in which you are going to divide your sample space, that will be known as partition of the sample space. These words are most important because they are going to tell you how to understand the crux of total probability theorem. Now if I have done this, let's move on to the mathematical consideration. So for reference, let's draw the sphere again over here. So I have a set of events which I have distributed like this, and now what I have done, I have taken up an event such that that event is nothing but taking bits and pieces of every part. Now see, A is the violet one, and all the event till An's are the red ones. So let's see how can I write. I can obviously write my total event A as small intersection of every possible partition of the sample space. Remember what I am saying. I can write my A as smaller portions of every partition of sample space and then joining them together. So what I am including right now by saying this, if I am saying that this is happening, so this part is included, this part is included, this part is included, this part is included, this, hence this, and so this. Now, once I have included all of them, so to get the complete answer, I need to add them. And add in terms of mathematics is nothing but union. Clear? So this is how we going to write our event A which we have considered. So if this is clear, so I think we can use the property of A1, A2, A3 till AN that they are mutually exclusive. Now if A1, A2, A3, AN are mutually exclusive, and suppose if I am taking a part of that is also going to be mutually exclusive. See, if I am taking something from a set of events, suppose A1, so I am pretty sure that I will not have anything from A2, A3, A4 till AN. Similarly, if I am considering from A3, I will have nothing from A1, A2 till AN. So which means if A1, A2, AN are a part of mutually exclusive events, hence their independent intersection will also be mutually exclusive. And if they are mutually exclusive, then by using the conditional probability, I can very easily write my union into summation because they are mutually exclusive. And if summation has been used, now I can use the conditional probability to write my intersection as probability of A1 into probability of A given that A1 has occurred. This is nothing but suppose this is the final format in which I am having my set of events, and I have taken something which is shown by blue. Now what I am saying is this blue one is A and the smaller sets are A1 intersection A, A2 intersection A. Now this is happening. See what I am saying? Probability of A1. First I am considering that this set is occurring from the sample space, and then I am saying that I am finding out the probability of this A given that this A1 has occurred. For every case I am doing the same thing. Probability of A2 given probability of A2 into probability of A given that probability of A2 has occurred. Similarly, probability of AN into probability of A given that AN has occurred. So don't you think in cumulative sense I am finding out the total possible case in which that event can happen? Yes? So see, it is something like this. I can go to my school either by my personal car, or I can go to my school. First I'll go to a bus stop and then I'll take a bus to school and then I'll go to the bus stop from to school. So if I have done this, which means I can say that for going to school I have two possible ways, and if I am encountering all the possible examples, so can I say that I have taken all the possible possibilities of going to school? So this is what is total probability theorem. If any event A is happening out of a certain sample space, then the total possible outcome in which that event can happen, and if we can find out the probability of that, that is what is found out by total probability theorem. So hence in totality we will going to sum up the probability of event A, and that can be written as summation of probability of AI into probability of A given that AI has occurred. And AI is what? AI is nothing but the ith partition in sample space. So I have considered all the sets of mutually exclusive and exhaustive partitions into the sample space, and then from each part of the partition I am taking only those values which are responsible for making A to be a successful event. So this is known as the total probability of an event A, and probability of A given AI has occurred is nothing but the contribution of AIth partition into the occurrence of total event A. Now, so if you have understood this totally, so let us make it much more firm by an example. The question says one bag contains 4 white balls and 3 black balls, and a second bag contains 3 white balls and 5 black balls. One ball is drawn from the first bag and placed unseen into the second bag. This is very important. This is the first thing that we have done. then the question is asking what is the probability that a ball now drawn from the second bag is black. So see, there are certain things which are happening into this question. First thing is that I have bag 1 and I have bag 2. In bag 1 the contains are 4 white and 3 black. The second bag the contains are 3 white and 5 black. So what is this saying? That one ball is drawn from the first bag and placed unseen into the second. So which means there is a transition which has happened. So one has come out into this. So the one that can come out from this to this can either be a black ball or can be a white ball, right? I don't know and we also don't know. So what, and the question is asking what is the probability that a ball now drawn from second bag is black. And what I am doing now, I am taking out a ball from the bag number 2 and I need to find out that the drawn ball is black. So see, if black is going to get inside into the bag number 2, then the count of black will increase and hence the probability of finding out black will increase. But if white is transferred from bag 1 to bag 2, which means the count of white is going to increase and the probability of getting a black ball is decreased. So let us consider that event A is something which is nothing but black ball is drawn from bag, and this can be distributed into two parts. Event 1 is that black ball is transferred from bag 1 to 2 and E2 is nothing but white ball is transferred from 1 to 2. Now see, can I say that from the total probability theorem, probability of A will be nothing but probability of E1 into probability of A given that even has occurred plus probability of E2 into probability of A given that E2 has occurred. So what is this? First case is saying that I am finding out the probability of finding out a black ball and then probability of finding out a black ball from the second bag given that the black ball was transferred, and second is saying that probability of finding out a white ball from the bag 1, and then second one that is in condition probability is finding out the probability of a black ball such that white ball was transferred from bag 1 to 2. Now what will be probability of even? Probability of even will be nothing. The black ball is transferred from 1 to 2. So black ball is transferred from 1 to 2. So probability of that is going to be 3 by 7 because 3 black balls are there into the bag 1 and 7 is the total number of balls. So 3 out of 7 will be the probability of black ball transfer. Probability of E2 will be nothing but 4 by 7. Now see, so probability of even is 3 by 7. Now I need to find out probability of A given that even has occurred, and probability of A is what? Black ball is drawn. Now see, if black ball is transferred from bag 1 to bag 2, which means bag 2 now contains 3 white and 6 black. So if this bag is having 6 black and 3 white, which means the probability of finding out a black ball will now become 6 by 9, right? And hence the probability of E2 is what? White ball is transferred from 1 to 2. Probability of E2 is nothing but 4 over 7. And the second part is probability of finding out a black ball given that white ball was transferred. So if white ball was transferred, the answer will be 4 white and 5 black. And the probability of finding out a black ball in this case will be nothing but 5 by 9. So what I can say the final answer is 18 plus 20 by 63, and this will be 38 by 63 will be the final answer. The probability of finding out a black ball from the second bag is 38 by 63, and hence the option number 3. I hope this question might have helped you in finding and understanding the probability, and we have much more newer and interesting concepts to explore on.
The understanding of sample space, algebra of events, mutually exclusive and exhaustive events, the understanding and solving ability of question into this part will help you very well into the understanding of the probability into greater extent. Now, so if you can understand this very properly and solve the questions accordingly, the total probability is going to help you into the examination, because questions are asked from this part. Now, if you can understand and do this, questions can be done very easily. So let's hope that you would have understood this part, and stay tuned for the next coming part.